In this video, we're looking at the surface area of prisms, cylinders, and spheres. Just a quick review, a polyhedron is a solid that is bounded by polygons that enclose a single region of space. A prism in particular is when there are two congruent faces called bases, which lie in parallel planes. That's a mouthful. So the top and bottom here are the bases, and then there's a lot of vocabulary here, some of which I talked upon before. We're only going to be looking at right prisms. Don't worry about the oblique prism. It's just when it's kind of slanted, so we're not really going to be worried about those. But the bases are the top and bottom. Now, so I could look at this particular prism, the floss, and I could have this part here be the bases, or I can rest it on its side, and then the top and bottom now here would be the bases. So it can vary for rectangular prisms. If it's a hexagonal prism like this one, the hexagon has to be the base. The lateral faces are the polygons that go up and down. The edges are segments. So I'm just going to underline the segments. And then the surface area is as if you wrap something up and you give it to somebody. How much wrapping paper would you need? So you're talking about the area of all the surfaces. And then we're only going to be looking at right prisms, meaning that this is a right angle here from the lateral edge to this. Okay, so let's get started. So let's look at where these formulas come from, and then we're going to do a few examples. So this is a triangular prism. And when we look at the total surface area, we want to look at all of the sides together. And so there are two bases that have area. So here the bases are the triangles, here the bases are the rectangles. So we need the area of those two bases. In addition, we need the lateral area. So when we do the lateral area, I'm going to look here at this rectangular prism's net. And I'm going to number this. So I'm going to say that this is number 1, this is number 2, this is number 3 in the back. It's hard to kind of do the one in the back. 3 and then 4 on the side. And if you look, if you go around the one in front, so 1 is the front, I'm going to go from here, 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 and here. Here, 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 and here. Each rectangle is going to get multiplied base times height, because the height of the figure here. So that height is going to be really, really important. We need to identify the height of the figure. This is the height, this is the height, this is the height, this is the height. So to find the area of section 1, I'm doing this dimension times the height. Section 2, this dimension times the height. Section 3, this dimension times the height, this dimension times the height. So this ends up being this times the height, this times the height, this times the height, this height. Well, that is our perimeter. So this pink segment is the perimeter. So this is why the formula is the perimeter times the height. And then when we do the total surface area, we're doing the lateral area, so this whole area plus the two bases. When we look at a cylinder, it's the same thing. So a cylinder is a solid with circular congruent bases. If it's a right cylinder, it's just perpendicular, but same idea. So this is your circumference, okay, going around. And if you lay it out, that is, so if I go around here, that is this part here. And then you have your height. The height here, the height there. Okay, so that is your height. So when you do the lateral area, you're doing the perimeter of the base, which we're going to call a circumference, times the height, and then we're going to add the two bases, and they're circles, so 2 times pi r squared. And then there's 1/3 formula, and it is the formula for a sphere, which is 4 pi r squared. A sphere, here's my cotton ball. You just need the radius, and then you use a formula. So it's really straightforward. Okay, so let's take a look at number 1. We're going to find the lateral area, the total surface area of the following solids, round to the nearest tenth. I strongly advise going through these 5 steps in order. So number 1 will be to shade the base and identify what you're looking at. So this is a prism. So this is a prism. So I'm going to call this a rectangular prism. I could add that you should identify the prism too. Rectangular prism. So I have a rectangular prism. I'm going to identify the bases and shade them. So I'm going to say it's sitting on the base. Bases could be left and right. And then you want to identify the height. So the height is going to be 8. Next, we're always going to find the perimeter of the base and the area of the base. So the perimeter of this base, I just kind of pick a starting point. This is 12. This is going to be another 4. This is 12. So 12 plus 4 plus 12 plus 4. So it's going to be 16. 16 times 2 is 32. And then my units is centimeters. And then the area of the base is a rectangle. So I added up the 4 sides to get the perimeter. Now when I do the area of a rectangle, it's just going to be 12 times 4 or 4 times 12, doesn't matter. And you're going to get 48 centimeters squared. So I shaded the bases of my rectangular prism, identified the height, I found the perimeter and the area of the base. So those are kind of straightforward. If you do those 4 steps every single time, you should be pretty easy to work with. All right, so now when I do the lateral area, it's the perimeter times the height. So the perimeter was 32 and the height was 8. So I'm going to take my calculator and do 32 times 8, and I get 256. Area is always in units squared. All right, now I'm going to do total surface area, which is the lateral area plus 2 times the base. So if you get the wrong lateral area, or if you have an error, it will follow you. So that's why we always want to see your work and what you're putting into the calculator. So that's really important. I'm a big fan of the answer button, so I'm just going to do plus 2 times 48, and I get 352 centimeters squared. So my lateral area is 256 centimeters squared. The surface area was 352 centimeters squared. I do want to mention to you, for rectangular prisms, if you pick different bases, your lateral area could potentially be different, only for rectangular prisms. But if I had done the left and right, then that's fine. The total surface area will be the same, but the lateral would be different. All right, so I did number 1 in the notes packet, and now I'm going to come over and do number 3 here. So this is a cylinder. Okay, same process every time. Highlight the bases. So the bases are the circles, pretty straightforward. And then the height of the figure in this case is going to be 12. This case, I have a radius. Sometimes you can be given a diameter, and if you're given a diameter, remember to divide by 2 to get the radius. These are really nice to use because there's not a lot of calculating, and you just go right into the formula. So I have 2 times pi times 8 times 12. So you can get the exact answer, and if you do that, you would just do 2 times 8 times 12. And I'm going to get 192 pi. So that's the exact answer. And this one's in centimeters. So centimeters squared. Now, if you want to do that with 3.14 for pi, then you would just multiply by 3.14. And I'm going to get 602.88 centimeters squared. All right. Now, for the surface area, I'm going to take that 192 pi, and I'm going to add 2 pi r squared. So 2 times pi times 8 squared. All right, well, 8 squared is 64 times 2. So this is 128 pi, and I'm going to add 128 to 192, and I get 320 pi. Okay, and now I can take that and multiply by 3.14. So the exact answer is 320 pi centimeters squared, or 1,004.8 centimeters squared. Alternatively, I could have just multiplied that out and did 2 times 3.14 times 64, gotten this number, and then added it to the 602.88. And I'm getting the exact same answer. So there's multiple ways to work these out on your calculator. Just be careful that you go step by step. If necessary, use grouping symbols. All right, and then the last type I need to show you is a sphere. So I'm going to do number 5 here. So you have a ball, could be like a globe or like a model globe, or it could be like planet Earth or other planets. But we're going to find the surface area of the following spheres, round to the nearest tenth. So I think I was supposed to round this one to the 10th too. So then it would have been 0.9, no big deal. Over here, round to the 10th. So I'm going to do S equals 4 times pi times 14 squared. I am going to give you the exact answer just so you have the experience of practicing that. So we're going to do 14 squared times 4. A motorcycle just went by my house, so it's nice and loud. So I get 784 pi centimeters squared, and then I can multiply by 3.14, and I'm getting 2,461.76. I was asked to round to the nearest tenth, so this is going to bump that up, so it's 2,461.8 centimeters squared, and that's how you find the surface area of a sphere. So just to recap, we're looking at surface area of prisms, cylinders, spheres. For the cylinders and spheres, you want to go through and always shade the bases, identify the height, find the perimeter of the base and the area of the base, especially for the prisms, and then you won't have any problems using your formulas. All right, have a great day.